Good morning, everyone, and welcome to our webinar on cold applied solutions for storage tanks. My name is Rachel Sharman, joining us from Belzona's marketing team.
I'm Luke Kerwin, one of the business development engineers here at Belzona.
And later, we'll be welcoming Henry Smith, Engineering Services Supervisor, for our Q&A. So today, we're going to be covering some of the areas where tanks typically experience damage and deterioration, and how you can use different solutions to repair, protect, and improve them. Now, please do bear in mind that the information and case studies shown today are a representation of what Belzona can do globally. However, they are not the limit of what we can do. If there's anything you see in this presentation which is of interest to you, at the end of the webinar, we will transfer you to our website where you can find your local distributor. From there, they'll be able to assist you with any tank maintenance issues you may be having. Good morning from Austria and Dubai. Very nice. But onto the webinar. So in the next 20 minutes, we'll be going over tank base sealing, nozzles and flanges, cold bonding methods, and internal linings for storage tanks. In this first section, we'll be discussing some of the common problems and solutions we see with tank bases, and also looking at the flexible and breathable Belzona systems used to prevent corrosion at the base of the tank. So now, I'll pass you over to Luke.
Thank you. So we'll start off by identifying some of the key common problem areas with tank bases in industry. So these being corrosion of the tank wall and the chine angle, deterioration of the seal, and also corrosion of the tank base. So to better illustrate this problem, here you can see our steel tank wall, our tank base, and our concrete plinth and what the tank sits on. So as you can see here that the tank base has deteriorated and broken up over time. So water will no longer be able to flow away from the chine angle, and instead it will sit here at the interface. So as the tank naturally expands and contracts, water will be drawn at this point by the capillary action, causing further corrosion at the base of the tank. So now that we know some of the common problems, we can look at some of the conventional repair methods. So first up, we have mastics and bitumen bases. However, the problem here is that they degrade very easily due to UV exposure, and as the tank naturally moves, they crack and lose their seal. Another common repair we see is steel skirt. However, this involves hot work, and as the newly welded steel isn't protected, over time it will start to corrode again. Finally, we have bonded rubber, which again, over time, degrades from the effects of UV and weathering, leading to regular replacement of the system, meaning lengthy downtime. So we'll now look at the Belzona solution for protecting tank bases. So the Belzona solution, as we can see here, is a flexible microporous system which adheres to both concrete and steel substrates, offering corrosion protection at the base of the tank. The Belzona system can be applied in service, and therefore there's no need to drain your tanks prior to carrying out the application. The system is also breathable, and it acts like a Gore-Tex jacket, so it stops any water from entering the system, allows any trapped vapors or moisture to escape through the Belzona, preventing corrosion from occurring underneath the tank. So we'll now look at some of the applications that we've carried out on various storage tanks from around the world. So here we have a very standard example of a Belzona solution, which has been applied to the base of a fuel storage tank. And over time, the structure of the tank has moved, and therefore the angular ring needed added protection. The customer decided to go with the Belzona solution, and 7 years later, as you can see, the base was inspected and still in perfect condition. Since the first application, approximately 50 tanks within the plant have now been coated. One of the many benefits of using the system is that the light colours allow continuous monitoring of the tank base, ensuring that no corrosion is present.
Another example comes from this refinery in France, which has had a Belzona system in place for over 13 years, still in service. Originally, the problem was due to movement in the tank, and the previous system had cracked due to its rigidity, as you can see in the top left picture. They opted for a membrane-based solution, which has flexibility, allowing it to follow the expansion and contraction of the tank, like Luke was saying. Overall, the refinery was very satisfied with this solution and still is. An added benefit for them is that they're able to use non-destructive testing methods to inspect the thickness on the steel ring through the flexible membrane. Our next case study took place at a petroleum company in China, which was having problems with moisture penetration at the base of their tanks, once again resulting in cracking. For this company, the priority was that the repair material must resist water, weather, and fire, all of which Belzona could provide with just one product. After the application, the customer was very happy with the results, and consequently, they ended up using this material on all 40 tanks across their site over the course of 2 years. Also, they specified the solution into the company's global standards. So those were just 3 case studies to demonstrate Belzona materials being used in the field. However, we have performed tank-based sealing applications all over the world. So if you're interested in finding more, you can visit our publicly available case study library, khia.belzona.com. There we have thousands of case studies to browse, so even if something isn't covered here today, if you visit that website, khia.belzona.com, there will almost certainly be a case study relating to your problem and our proven solution. So now we're moving on to the next section, and we'll be covering some conventional methods for the protection of small bore nozzles and flange faces. We'll also look at the Belzona solution for these tricky application areas.
So the main problem we see with flange faces within the industry is corrosion on the flange face. So this can be caused by several factors. One of the main causes being galvanic corrosion, which is when we have 2 dissimilar metals in contact with one another. Some of the common types of attack we may see is crevice corrosion, steam cuts, and also chemical attack. Some of the conventional methods for repairing flange faces would include welding and cutting back the flange face. However, unless it's machined, it can be very tricky to produce a gramophone finish. Another common method is to cut and replace the flange. However, both of these methods include hot work and therefore present the associated health and safety risks that are involved from welding. So now that we've covered some of the common problems and methods, we can take a quick look at the Belzona solution for repairing flange faces. So how does Belzona flange face swarming work? So the Belzona solution is cold applied, and it uses Belzona paste grades to recreate the sealing face using a mold designed to replicate the original dimensions of the flange face. So the Belzona solution is 100% epoxy and contains no solvents, so the exact dimensions can be formed. The Belzona solution is also an electrical insulator, so eliminates any metal-to-metal contact, which means the risk of galvanic corrosion is also eliminated. The next area we'll be covering is small bore nozzles. So how do we protect nozzles with a 4-inch diameter or less? Often this applicator is left to contractors who paint very much on a best efforts basis. This is due to the very limited access, which makes it very difficult to achieve an ideal surface preparation and also an ideal coverage of the protective coating within inside the nozzle. The conventional solution for dealing with smaller nozzles is to cut and replace the nozzle. However, this requires hot work and will not eliminate the problem, or as mentioned, to paint on a best efforts basis. So now that we've identified these conventional solutions and their drawbacks, we can take a look at the Belzona solution. So the Belzona solution eliminates any guesswork with small bore nozzles and ensures 100% coverage of the protective coating. So we can do this by prefabricating a section of pipe made from a suitable Belzona material. This is then bonded in place using a Belzona adhesive, which will offer an optimum long-term protection for corrosion, erosion, and/or chemical attack. However, nozzle inserts and flange face forming techniques are not just limited to damaged equipment, but both systems combined can also be implemented as part of the design for newly fabricated vessels. So these Belzona solutions have been used with carbon steel instead of solid, corrosion-resistant alloys for the nozzle and/or weld overlay for the flange faces.
This case study took place in Spain at a chemical manufacturer. Here, the interior of an ebonite line nozzle handling 26% hydrochloric acid had suffered damage from the acid and needed a replacement. However, relining the ebonite would not have been a very cost-effective solution, and therefore a Belzona nozzle insert was chosen to be installed instead. Not only was this better price-wise, Belzona's system had excellent chemical resistance, so will last for the long term. Plus, the application allowed a fast back-to-service time for the tank with its easy in-situ repair. So moving on, it's great to see so many of you saying hello from all around the world in the comment section. Now, in this next section, we'll be talking about how you can use cold applied solutions for plate bonding when carrying out work on the outside of the tank, whether that be the wall or roof. So to start with, Luke's going to look at the most common solution for plate bonding, welding.
So when we talk about adding strength back into the structure of a substrate, welding a plate onto a defect area is a very common method of repair. It provides a strong bond and is a very well-established method. However, before a tank can be welded, it must be drained, which means lengthy downtime and also a loss of resources. So welding also creates a heat-affected zone, so it introduces heat stresses into the metal, which can result in further problems such as cracking later down the line. And as always with hot work, there'll be health and safety risks. Another downside to welding is that there's actually fewer points of contact when welding, which leaves a void between the plate and the wall. So this very simple animation demonstrates a plate being bonded onto a metallic substrate. As we can see, the plate is only bonded to the substrate at either side of the plate edges. So these are the only 2 points of contact at which the load is transferred between the plate and the wall. So if there was a through-wall leak, for example, this gap would fill up with fluids, allowing the plate to be very susceptible to crevice corrosion. And as mentioned previously, these welded areas have also created heat-affected zones. So this will change the microstructure of the substrate, which again could cause cracking later down the line. So we'll now look at the Belzona solution for bonding. So as demonstrated on the screen, the Belzona solution offers 100% contact on the substrate, which gives an excellent load distribution. The Belzona material, also being non-metallic, acts as an electrical insulator, eliminating any potential for galvanic corrosion and therefore offering a long-term corrosion protection. So now that we've gone over welding and understand how cold bonding works, we can look at the different types of cold bonding solutions. So metallic plate bonding has been successfully used for over 20 years as a repair method. However, in recent months, composite plates have also been used to offer non-metallic solution. So if you want more information on non-metallic solutions, you can visit us on Belzona for more information or watch our previous webinar on composite repairs. So some of the positives of using the Belzona solution include no downtime, as no hot work is required, and therefore no requirements to drain the tank. Cold bonding techniques can also be used to repair thin and through-wall defects, extending the structure and equipment beyond its original design life. So we'll now watch a video on welding versus cold bonding techniques.
I'll just put that on the screen for you.
Demonstrating the pros of cold bonding versus welding. We attached 2 brackets to a tank. One was attached to the tank via welding and the other via cold bonding. Before we began, we marked out the perimeter of the brackets. For the welded bracket, we prepared the surface area outside the perimeter since welding is done at the edges. We then proceeded to weld the bracket. As you can see in this video, the tank lining started burning as soon as we began welding. We had to stop welding for safety reasons. For the cold bonding application, we prepared the area inside the marked perimeter since bonding is done on the whole surface of a bracket. We then prepared the bracket. Next, we masked off the application area. We proceeded to clean the area to remove any loose particles. We then mixed our bonding material, which in this case was Belzona 1212. After mixing, we applied a thin layer to the application area with a stiff bristled brush, pressing hard to make sure product fills the profile. We then applied a thin layer of the product to the bracket surface, and more product was applied to build a central peak. We proceeded to attach the bracket to the tank by pressing it with force onto the application area, making sure the product squeezed out of the sides. We cleaned the excess product off the edges of the bracket. We took temperature readings via thermal imaging, as you can see in this video. A maximum of 80 degrees Fahrenheit was reached, which is safe for both the tank lining and content. And removed the masking tape to finish the application. Cold bonding is a more practical and safer choice. Here are a few samples of other cold bonding applications: live leak repair on a tank, mounting a ladder or cell phone antenna to the side of a tank, or even repairing the weld seams by injection.
For now, though, we're going to move on to the case study section. So the first case study was prompted by legislation change in China. This meant that VOC treatment was required to be implemented on all oil tanks across the country. This required the customer to attach pipe rigs to the tank wall, but with hot work restricted in the tank farm, a cold bonding solution was necessary, and therefore Belzona was the ideal solution. To begin with, for this application, they used vapor blasting to prepare the surface. This was necessary as grit blasting was not allowed in this ATEX rated zone. The applications were a big success, and the customer was very happy with the result. So much so that after the first application for 18 tanks, they decided to use the system for more than 200 around the region. And here is a similar case study, but in the Netherlands. We chose these case studies to show you that cold bonding can be used for plates and so much more. In this case study, the company wanted to bond a water sprinkling system and a foaming system on top of their oil tanks. However, once again, hot work and grit blasting were banned on site, obviously. Therefore, for each tank, the substrate was prepared, this time with a dust-free blasting system, in order to achieve the right surface roughness, without generating dust and any potential fire hazards near the oil. In total, over 1,000 brackets and supports were bonded onto the sides and tops of 8 different storage tanks, again leaving another satisfied customer. So our presentation is almost finished, and this is our final section before our Q&A with the engineers. So you can start thinking of some questions, but for now, we're going to look at internal linings, specifically for the protection of the floor and bottom sections of storage tanks.
So a common problem we see in storage tanks is corrosion on the internal surface of the tank. However, generally the only affected areas by corrosion is the tank floor and maybe 1 or 2 meters up the side of the tank wall. So this is because of a mixture of water and hydrocarbons in the tank. And as the density of the water is higher than the hydrocarbons, the water will sit at the bottom of the tank, which is where the corrosion will occur. So now that we've identified this problem and the reasons behind it, we can take a look at the range of solutions that Belzona can offer to protect these tanks. So Belzona have a varied range of products which can be used to restore the damaged tanks. Paste grades can be used for pit filling, and plate bonding methods can be used for the larger areas. So once the structure of the tank has been restored using these methods, the tank will then be coated with the most suited lining based on the operating parameters of the tank. The lining will then be able to offer corrosion resistance in immersion, steam out resistance, and also chemical resistance. So we'll now take a look at a couple of different internal lining applications on storage tanks around the world. So here we have an oil company in Tunisia who are experiencing severe pitting at the bottom of their storage tank. And as this was a rivet tank, welding wasn't an option, otherwise the rivets would pop off one after another. The Belzona solution here was to pit fill the smaller localized pitting and then use plate bonding for the larger areas. The tank was then coated with a Belzona lining, which was selected based off the operating parameters of the tank. As the corrosion was due to a mixture of water and hydrocarbons, only the floor and the lower section of the tank wall, as you can see in the pictures, were coated. Again, here we have a very similar problem in a petrochemical plant in Italy. A mixture of water and hydrocarbons were present within the tank, resulting in pitting at the base of the tank. The Belzona solution was to pit fill the localized damaged areas and to use an internal lining based off the operating conditions of the tank to coat the floor and also the bottom section of the tank wall again. So this type of repair is something that Belzona is very experienced in, and due to a wide range of internal linings, we can make sure the correct lining is selected based off the individual operating parameters of each tank.
So don't forget what I mentioned earlier. If you're interested in learning more about these case studies, check out our public case study library, khia.belzona.com. For now though, please start typing in your questions to the chat box and we'll answer as many as we have time for. We hope that in the last 20 minutes, we've given you an insight into how Belzona solutions can be used for tanks, even though there's honestly so much more we could have covered, such as flange encapsulation, floating roofs, external protection. We wanted to keep this webinar not too long. But if you are interested in learning more, we can direct you to your local distributor who will be able to talk you through the full range of what they can provide in your local region. For now though, thank you for watching our presentation and let's move on to the questions. For nozzle inserts, what can you bond it with?
Pretty much any Belzona coating that you want to. Again, depends entirely on the process that you're looking at. We can do it with, a lot of the time we do it with 1321 because it has a really good adhesion to steel. But if it's not erosive service, the chemicals are slightly different, it's a higher temperature, you could potentially use any of the other Belzona coatings. Again, some we have tested, some we haven't. So it would be up to yourselves maybe to do a trial beforehand, or we could do a trial necessarily.
What level of surface preparation is required for internal pit filling and small areas of internal corrosion?
Making a film.
Okay. So for surface prep, if it's for internal, so it's going to be in contact with the process or the liquid or whatever is inside the tank itself, then we'd always recommend grit blasting 100% of the time. That gives you the best possible bond, and even if this is being covered with a coating, you want that pit fill material to stay in the pit. You don't want it coming out from underneath the coating. So 100% grit blasting. Some cases there may be chances where maybe you can't do grit blasting because of hot work restrictions and things like that, in which case we can look on a case-by-case basis and maybe go down to something like a bristle blaster or grinding, but it's very much depends on the situation.
Can we repair damaged PTFE internal lining with spools or nozzles? If yes, what's the product?
Potentially, yeah. PTFE is one of those materials where adhesion's a bit of an unknown, because with steel we know that Belzona adheres to it, and with PTFE we tend to do a lot of testing specific to that application before we suggest the product. So it depends what type of repair you're after doing. So I presume if it's just an internal lining or nozzles and things, it's just patch repairs. Potentially yes, but we'd have to look at adhesion testing. We'd have to maybe do a trial of it first just to make sure we get the correct level of adhesion before we start applying the Belzona products.
Would you consider the application of a Belzona lining to be easier than applying a fiberglass lining system?
I might be slightly biased in this, but I'd say yes. So with fiberglass, again, they perform quite similar roles, but the fiberglass itself, there's a lot of in the health and safety implications of the fibers that you're using. And with the Belzona, it's safe materials. In most cases, they're solvent-free. There's no health and safety implications. There's no need for any breathing apparatus or anything while you're using them. You open the units, mix them, apply them to the prep surface, leave it to cure, and that's it. There's nothing else to it.
Perfect, thank you. Next question is there any product we can use without surface preparation in the case of a pipeline leak? Maybe the leak is the size of 3 to 4 millimeters. In case of a MOGAS line leak, hot work cannot be done, and even if fuel is doping by gravity, no pressure.
So basically asking, can we use any products without surface preparation?
Yes, basically.
Not really, no. We have seen applications before where no surface prep has been done, and as Luke said earlier, no mechanical prep or no prep whatsoever will mean that the product physically doesn't work, and we need something for that product to adhere onto. So if you've seen our live leak applications before where we've used the 9611, this putty stick, where you mix it in your hands and you plug a hole with it, even that needs some sort of mechanical roughness to it before. It doesn't matter if it's wet, that product's fine for it. There's designed for live leak sealing. But you need to use a file, a wire brush, some emery paper, something to give that a key to stick into. Because if it doesn't have anything to stick into, it's literally just the chemical bonds of the product to the steel that you're relying on, which is good, but not enough to retain a certain amount of pressure. So again, they always have some sort of mechanical prep.
For tank-based application, which types of inspections can be done after completion?
Yeah, so we were just talking about inspecting the angular ring after applying tank-based sealing. So just basically any non-destructive testing methods. So you can use ultrasound. So it won't actually, I don't know, it won't.
The Belzona doesn't interfere.
That was the one I was after, yeah.
It doesn't interfere with it. The main one would be UT, and we looked at other things. There's a lot with the composite repairs, especially like X-rays and that sort of thing. But generally, it's not necessary. But if you wanted to, like Luke said, ultrasound is a really good one. Or as the guy suggested earlier on, maybe low voltage, like sponge testing, that sort of thing. Something that doesn't affect the coating, so NDT, basically.
For tank-based sealing, what is the application temperature limitation of Belzona 3111? Since we're observing substrate temperatures of close to 50 to 55 degrees Celsius.
Pretty
Probably.
warm, yeah.
Yeah, Middle East perhaps?
A bit warmer than the UK,
Definitely.
So for 3111, the maximum temperature we normally suggest is about 40 Celsius, because it's a water-based product. So as soon as you open that bucket, all that moisture is going to want to evaporate out of it. And once the moisture's gone, you're just left with the layer of product on top. If you are applying it in extreme conditions, generally say apply it when it's in a shaded area, you cover it over, or you do it later on in the afternoon when it's getting colder. But if you absolutely have to, then when you open the bucket to apply the product, you pour a couple of centimeters of water. Don't mix it into the material, just leave it on the top. So when your brush goes in and it picks the product up, it gets an extra layer of water on it and allows you a few more minutes of application time before that water starts to dry off. But you'll find as soon as you put it on the surface, it's pretty much gone immediately. So you have to be very, very quick.
After Belzona 3211 applications in tank-based sealing, we've observed some insect cuts or holes in the Belzona product. How can we manage this?
Just kind of you can just make sure where the cuts are, it's cleaned out. You can roughen the surface up again and just kind of apply a bit more 3211 with some reinforcement sheet over it.
Yeah, I must admit it's not something we've ever had to test or to put in to say how to avoid insects cutting through it. But the 3211 is very, very easy to repair. Minimal prep, as long as it's clean and has a tiny bit of roughness to it. You can reapply another layer with minimal prep. And that's the only thing we can suggest for that sort of issue.
We've also just had a message from our Thailand office saying that for the insect bites, pesticides might work if you consider using them. Are Belzona products sold for self-application, or do you provide the service?
Both. You can either buy the products, or you can potentially speak to your local distributor about carrying out the service as well. So that's something you can speak to them. So we can put you in contact with your local distributor.
Everyone who's registered for the webinar will be sent the recording and the transcript, which has all of the information written out, so it's easy to access and go back to. We'll also be hosting the webinar link on our YouTube channel, so that's YouTube.com/Belzona TV, where you can also find links to all of our previous webinars that we've run this year and last year.